Good morning, all my students of class 12. So today we are going to derive a very important integration formula, that is integration by parts with the help of derivatives. So before going to that, we should not forget she is Maria Gaetana Agnesi, a woman who has written a first book relating differentiation with calculus. So, to derive the integration by parts with the help of derivatives, how to do it? Let us take two functions u and v. Then we know that d by dx of uv is equals to u plus, we know that we can write this in the form of this, which you have learnt in class 11. Now doing integration, integrating both sides, integrating both sides, what we get here uv is equals to now let us bring this to left hand side. We get so from here let us consider u be a function of, let u is equals to f of x and so from here what we can get is du by dx is equals to f dash x, and from this we get v equals to integration of this. Now putting those values over here, so what we get here is, from still we get uv minus this is equals to u dv by dx. Now instead of u we can write here fx, and dv by dx is equals to 5x dx. So from here we can write this as integration u means f of x dv by dx, we can write 5x now here uv, what is u is f of x, and what is v is the integration of this, that is u is the first function, we are writing here u, and instead of v we are going to write this integration of minus what is v, we know the value of v, and du by dx, that is f dash x. V is the integration of, so we are writing here minus, then let me write here integration of, after minus I am writing here what is v, is this, that means what, integration of five x dx. What is du by dx? Du by dx is f dash x. So this, after that this must be equals to this. So from here what we get is integral of first function, integral of the product of first function into product of second function. That means the integral of the product of two function is equals to what is u? What is u? U is the first function that we can write here. First function multiplied by integral of second function then minus what we have to do minus here is integral of differentiation of first function multiplied by integral of second function. Integral of differentiation of first function integral of differentiation of first function multiplied by integral of second function. This is an important derivation which is very useful for calculus. So my dear students, so this is one of the very important formula I'm going to derive through doing integration by parts, and it is very useful for your board examination as well as in joint examinations to do the problem within 30 to 40 seconds. Try to understand how to derive it. So to evaluate this, so let us take this as I equals to integration of e to the power of x fx plus f dash x. Now let us split this integration of e to the power of x fx dx plus integration of e to the power of x f dash x dx. Let us assume this I1 plus I2. Now considering I1, here I1 is equals to integration of e to the power of x f of x dx. See here my dear students, let here the two functions are there, e to the power of x is there and e to the power of fx dx is there. So let us consider this as a first function and this as a second function, and with the help of integration by parts let us do the integration of this. So this can be written as, this is the first function, so through the formula just now we have read that first function into, here we are taking this as a first function as I said you, and this is the second function. It perfects, you can take as a second function to do it very easily. So doing integration by parts, what we can get is first function into integration of second function minus integral of differentiation of first function is f dash x into integral of second function is dx. Now this can be written as f of x, integration of this is e to the power of x minus f dash x into e to the power of x dx. Already we know that I is equals to I1 plus I2. So we get here I is equals to, what is I1? We can write the I1 here, that is f of x e to the power of x minus integral of f dash x e to the power of x dx. And what is I2? I2 is plus integration of e to the power of x into f dash x dx. My dear, now see that this is being cancelled out, this and this being cancelled out, so your answer becomes I is equals to function of x into e to the power of x. That means simple, in this type of format we can just write the answer directly, that integration of such parts will be equals to f of x. F of x was the first function into e to the power of x. So in board exams also you can go over this, and in joint also. Let me show you with one example. So this is one more important question. We have to find out the integral of this. But my dear students, don't get panic. Just now whatever I have taught you, with that we can do it very easily. At first you must simplify this. This can be done as simplification. This in the rough work you can do it here. You can write here 2 minus sin 2x means 2 sin x cos x by, here 1 can be written as cos square x plus sin square x minus cos square x minus 1 plus sin square x. So from here you can take here 2 common, so we can write 1 minus sin x cos x divided by, from here it is getting cancelled off, we get here 2 sin square x. This get you cancelled here, and if you split here it becomes cosecant square x minus this get cancelled off, so we get here cot x. Now see here, the differentiation of cot x is minus cosecant square x. So if this can be taken as f of x and this is as f dash of x, then with the help of the formula we can write this as e to the power of x. This can be written as in the form of cosecant square x minus cot x. See here, this is fx and this is f dash of x. So final answer we can get here minus e to the power of x cot x.